This is the relative permeability workbook. It contains 3 tabs, one per system: all water, all gas, and gas and water. And before those 3 tabs, I have this equations tab, which contains the very formulas used through the workbook. Now, there are a couple of links here at the top. These are live links that take you to the very sources where these formulas came from. And also at the bottom here, I'm pasting from the Eclipse manual a consistency requirements section for you to make sure that you are being consistent with your entries in your saturation tables. It also explains the nomenclature used, a nice schematic to understand the relationships between the saturation endpoints. Also here, the nomenclature explained in each phase: gas, oil, and water. And finally, at the bottom, I have this keyword families, where you can see which are the keywords that you need to use when generating your tables. Okay, now if we move on to the all water tab first, you can see that we have at the top a bit of a dashboard with a couple of charts and the sliders, and at the bottom we have where the calculations actually are conducted. So at the top, you can see that the sliders, you can just drag them, and the charts update in real time. So you can see the impact of each parameter on the graphs. Just displace the slider. You can see how each endpoint moves. Red perms, capillary pressure here at the bottom, which is the chart on the right, saturation endpoints, relative permeability endpoints, and the exponents, which control the shape of the curves, as you know. Okay, at the bottom here, I also have the opportunity for you to export the tables in Eclipse format using the relevant keyword. So the path is where you type in or paste the folder path where you want the file to be dropped in. Now here's where you type the file name. Now if you select that checkbox, when running the macro that generates the file, a notepad instance is opened where you can immediately visualize the table generated with the relevant keyword. In this case, SWOF, because it's an all water system, and the 4 columns. Okay. Now here is, like I said before, where the calculations actually take place. Now, if we have this range selected, you can see the count. We have 10 lines, so there are 10 entries in the saturation table, and I work my way through to the right to end up with the strings, which are actually the ones that end up in the file being exported. Okay, now this is just a construction of the preceding columns that I have here, and these are again consolidating from the preceding columns where the calculations actually do take place. Now we can see that the saturation here, this water saturation column, the lowest saturation you can see comes from C4. So if I double click on it, it's highlighted. That's the Conway water saturation. That's the lowest saturation in our table. The maximum saturation is 1, but sometimes it's not going to be 1 because I have a formula here. If the residual saturation is 0, it shouldn't be 0, but if it is 0, that turns into an NA entry because the preceding one is 0. If it's not 0, I want to actually have the residual oil saturation in the second to last one entry. So the colored cells are special cells that need special attention. Like I said before, the lowest one is the Conway water saturation. The second to last one, I want it to be the residual oil saturation. So saturation of oil is going to be that one, the residual saturation, 0.05, and this is going to be 1 minus, so 0.95. Okay, and again, in that case, the max saturation in our table needs to be 1, in the case we're below the contact, so it's just water. But if that is 0, that means that that second to last one turns into 1, and I don't want to have a repeated entry, so I turn that into an NA entry. That, what it does is, it doesn't affect the charts in Excel, but also it prompts that this line here is commented out, so that's a formula. So if that is 1, then comment that out with that double dash, and it's an empty line, so it won't affect the simulation either. Okay, so in other words, I have 10 entries in the table. I work my way from the minimum saturation in the table to the maximum saturation in the table, and in between is just a regular spacing to end up with 10 points. And the colored cells that you see through the various tabs are the ones that require some special attention. In the oil gas case particularly, we need to work out an inverted. You see here this formula is to invert the order because the requirement is for the saturation to be increasing in the table. And since we work from the saturation, from the liquid saturation here, we need to invert that. So all of this kind of stuff is already taken care of, so you don't need to worry about. All you need to do is to make sure that you're happy with your real perm definition up here as you visually see it on the charts by moving the sliders. And once you're happy, you don't worry about formatting any of this stuff. It's all done for you. Just generate your export file by hitting that button that triggers the macro that writes in a text file the strings that you see here. So again, in this case, it's an oil gas system. Therefore, the keyword is SGOF, which is the one you see here. So those are the strings that end up in the include file. And finally, the gas water saturation, the keyword is SGWFN. And again, same deal. You play with the sliders, move the endpoint saturations, endpoint real perms, and exponents for the shape, real perms, and here capillary pressure. So fairly intuitive and user-friendly. Again, in the equations here, you can see the very formulas used in here. You see here, those are formulas that are the ones actually listed up here in these equations tab. Okay, now this is obviously a simple railperm version. You can start wondering about multiple regions, multiple railperm curves for all those different regions. You can think about drainage and imbibition curves, or you can think about endpoint scaling, all that sort of stuff. But this is a foundation for you to start with, and you can go one curve at a time. This is mostly to do with you making sure that you understand the impact of each parameter on the curves, and visually being satisfied with the curves you're actually sending to your simulation, and again, using the simplicity of Excel without having to go to third-party software. It's not meant to be an all-in-one solution for all cases. So just take it as it is, and I hope you find value in it. Cheers.